Can humans become a power source in the future? Asterisk Part 1. The beginning of the idea, asterisk, from the moment we're born, our bodies begin producing energy. Whether it's the electric signals in our brain, the calories we burn while running, or the heat we emit when we're asleep, our existence is a constant flow of energy. But in a world where we're searching for clean, sustainable power sources, one bold question emerges. Can humans themselves become a power source in the future? Asterisk it. Sounds like a concept pulled straight from science fiction, like The Matrix, where machines used humans as living batteries. But this idea isn't just fantasy anymore. With the rise of bioengineering, nanotechnology, and renewable energy research, scientists are starting to seriously explore how the human body could one day be used to generate usable energy, not just for survival, but for powering machines, cities, and possibly even the planet. Asterisk, let's take a moment to understand what kind of energy the human body naturally produces. Our body runs on chemical energy, generated through a process called cellular respiration. When we eat food, our body converts glucose and oxygen into ATP, adenosine triphosphate, which acts like fuel for our cells. That process releases heat, kinetic energy when we move, and a small amount of electricity, especially in the nervous system. Every heartbeat, every blink, and every breath involves a complex energy exchange that keeps us alive. Asterisk, but how much energy do we actually generate? On average, a resting human body emits about 100 watts of power, which is roughly the same as a light bulb, during physical activity. This number can spike dramatically. Cyclists, for instance, can produce up to 400 to 600 watts during a sprint. When you start to multiply this by billions of people, the theoretical total becomes staggering. The global human population could collectively produce hundreds of gigawatts if we could tap into even a fraction of that energy. But tapping into it, that's the real challenge. Asterisk, the idea of harvesting energy from the human body is not entirely new. In fact, there are already small-scale technologies that do exactly this. For example, thermoelectric generators, TEGs, can convert body heat into electricity and have been used in wearable tech like smartwatches. There are also piezoelectric materials, which generate power when they are compressed or moved. Think of special floor tiles that generate electricity when people walk on them. Some researchers are exploring nanogenerators that can sit inside your body and convert motion from your heartbeat or blood flow into tiny amounts of electricity. Asterisk, now imagine scaling that up. Imagine a future where your daily movements, walking, typing, breathing, are all captured and turned into power. What if your smartwatch didn't just measure your heartbeat, but also charged itself with every pulse? What if your body heat kept your phone running? What if a gym could run on the energy of the people working out in it? These are no longer far-fetched ideas, they're real possibilities. Asterisk, however, transforming humans into meaningful sources of energy on a large scale requires major breakthroughs in energy conversion efficiency. Right now, the energy we generate is mostly used by our bodies to keep us alive. Our systems are not designed to spare energy for other uses. Trying to divert some of that power without harming our health would be like trying to power a house. Using the battery of a small remote it just isn't feasible yet. But what if we didn't need to take energy from inside the body? What if we could just collect the wasted energy we're already losing? Asterisk, this brings us to one of the most promising areas of research: harvesting waste energy. Every day, we lose energy in the form of heat through our skin, through exhaled air, through friction in our joints. Scientists believe that if we could capture just a portion of that wasted energy, we could create sustainable, human-powered micro-energy systems. Think of a jacket that captures your body heat and charges your phone, or socks that gather the motion of your footsteps and light up your home at night. Asterisk, the most exciting part? This kind of human-powered energy doesn't have to be large-scale to make a difference. In areas without access to electricity, remote villages, refugee camps, or disaster zones, a single device that turns body movement into electricity could be life-changing. Imagine a backpack that charges a battery as a child walks to school, or a hospital bed that uses the patient's breathing to power a medical sensor. These are small, individual-level applications, but they prove that the concept of humans as power sources is already here, in its early form. Asterisk. But what about the ethical questions? Could turning humans into energy sources go too far? There's a thin line between harvesting energy and exploiting people, and this concern has been raised in many philosophical and scientific debates. Would this new power model be voluntary or forced? Who would own the energy your body creates? In a world obsessed with control, could this technology be misused? These are not just questions for scientists, but for ethicists, lawmakers, and society as a whole. Asterisk, still, there's a more hopeful vision too. A future where humans are not just consumers of energy, but contributors to it. Where your body, your life, your presence has literal power. This is a future where every step you take, every breath you draw, adds a little bit to the energy web of the world. A future where power is not just something that comes from coal plants or solar farms, but something that flows naturally from life itself.